So last class we have seen regarding uh, basic term width, and today we will see improved ranking. So let me just remind once again what we have seen in our last class was Occupy model. In Occupy model we have seen basic calculating basic term width. So now so using this formula given here, we have seen calculations regarding this particular documents given, and we have seen calculation for each term. So in the query it may be given only for particular term, but for this you for this particular example we have calculated for all the terms. We have calculated for call, we have calculated for day, we have calculated for each, we have calculated for all, and for all the terms we have calculated, and the corresponding weights are given down below here. And calculation we have done here, how to calculate for a term. For code, calculation is given like this. Capital N is the number of documents, total number of documents, while small n is the frequency of the document. So that means term frequency. And we will see improve ranking. So the Occupy model is also known as BM model. BM model is nothing but best match. So BM0 is for improved ranking model. Improved ranking is also known as BM0. So in BM0, we will be BM0 model. By BM0 model, you need to calculate improve using the improved ranking model. So let us see. Here we can see last class also I have already explained about this. There will be capital R and small r. Capital R and small r. So capital N, as we already know, capital N is the number of documents in the collection, whereas capital R, they are the number of documents which are non-relevant. Number of documents which are non-relevant. And small n is the number of documents containing the particular term, and this small r is also the number of documents containing the relevant document. This is frequency for a particular term in relevant document. So we will see the example so that we can understand this properly. So here in this example, you can see before we go to the example, calculating the final term width. So calculating the final term width, we have documents containing the term, documents containing the term. If it is in relevant document, it will be represented by small r. So we will be counting the number of documents. Okay, remember this. We will be counting the number of documents that contain the particular term r, the particular term t. So in relevant document, it will be r, and for non-relevant document, that is n minus r, and for total it is n. So that means if you have for the particular term total number of documents, if you are going to count that contain the particular term t, then that will be small n. Small n is number of documents that contain the particular term t. And relevant for relevant document, if it is counted only in the relevant document, that will be represented by small r. That means for non-relevant it will be obviously n minus r. Documents not containing term. So if you are going to count the number of documents that does not contain the particular term which we are going to find, then R minus R, capital R minus R. And if you are going to count for documents not containing the term, N is the total number of documents minus R. This is nothing but your relevant documents containing the term, documents containing the relevant. So this is this the scenario for estimating your term. One second. So again, it is written down here the explanation. So let us directly come to the example. So example, the formula for finding the final term which is given here. So you know what is R, small r, you know what is capital N, you know what is capital R. So let us first find out for this particular example. So the same example we have calculated here, we are going to calculate using the improved ranking. So this one, the first one is calculated using the basic term width, and the second one we are going to calculate using the improved ranking. So in improved ranking, we need to find the final term width. So this is about the improved ranking. In improved ranking, we use relevant document and relevant document frequency. So here in the example, it is given that document 2 is relevant. Document 2 is relevant. Now, let us find out the uh, final term width for call. So, final term width for call. So, you substitute the values. For R. What is the value of R? Small r, what is the value of small r? Can anybody tell me what is the value of small r? We are going to count the final term, we are going to calculate the final term width for uh, this one, coal. Final term width for coal. Now, what is the small r value? Small r value. Am I audible to you?
Yes, ma'am.
Yes. Then, what is the small r value? What is the small r for coal? So we are going to find for coal. So let me just add this slide and let us find for coal. So this is final term width for coal. Final term width for coal. Okay. Now tell me what is the final term width for coal? What is the value of small r? Small r, I told you, we are going to count the number of documents that contains that particular term call in relevant document. We are going to check in relevant document. We are going to check in relevant document. We are going to check in relevant document. So what is R? Tell me small r. What is small
Then,
r?
then is it 0?
Yes, it is 0. It is 0. You have to this one understand it properly, no? So R and capital N is little different here. Small n, small r, small capital R. There are four parameters here. So listen this very carefully. There are four parameters here. As I told you, n is nothing but what? Number of total number of documents in the collection. So total number of documents in the collection. So our collection, where is our collection here? So this is our collection. So how many documents are there? One, two, three, four, five, six. So this one is very easy. So we have six documents. That's why I have already written here also. So anyway, let me write it here once again. Capital N equal to 6. Now capital R. What is capital R according to this example? What is capital R according to this example? What is capital R according to this example? What is the value of capital R?
Oh, 1.
Yes, R is 1. Why? Because number of relevant documents. Number of relevant documents. So here, as I told you, the highlighted one is relevant document. Last class also already I have informed regarding this. So the highlighted one, it shows that this is relevant document. Suppose if I say document 2 and document 3, these are relevant. If I say these are relevant, then this 2 and 3 are relevant. So we have two relevant documents, then our capital R will be 2. Okay. So, but for this particular example, I am saying relevant document is 2. Document 2 is relevant. So capital R will be 1. So here capital R is equal to 1. So I am finding for coal. Okay. So this is for coal. Now let us check small r. In the formula, small r is there. What is small r? Small r is nothing but what? Number of 11 documents containing term T. So our term is call. With this call, we are going to check if it is there in relevant document or not. So in relevant document, we have only P, for each, and pot. We have only document 2 is relevant. In document 2, P, for each, and pot. Coal is not there in our relevant document. Coal, this term coal is not there in our relevant document. So small r value here will be 0. Small r here will be 0. Okay, now get small n. Now we have to find small n. So we need four parameters to calculate the final term width. So small n. Small n means what? Small n means number of documents containing the term T. Number of documents containing the term T. So we are going to check call is present in which documents. So call is present in D1. So one time here. Call is present in D4. So 2. Because call is present only in document 1 and it is present in document 4. Document 1 and document 4. So we are going to write small n equal to 2. Small n equal to 2. So clear? Is this clear for all of you? Is this clear for all of you? Pinky Chaudhary, are you clear with the parameters assignment? Who is Pinky Chaudhary? I don't have any names in my list called Pinky.
Hello,
Yes, this Pinky Chaudhary is who?
ma'am. Uh, I am Shweta Chaudhary. Pinky Chaudhary is my sister. My phone was not loading. My phone is having some problems,
Okay,
so
okay.
I
Okay,
have
okay.
login from her phone.
Sweta, okay, fine. Sweta, did you know the assignment of these values? The
Ma'am,
assignments given here n equal to 6, r equal to 1, r equal to 0, and n equal to 2, which you can see in this slide. So, do you know how these values are assigned?
no, ma'am.
And what were you doing? I have been explaining from 11:15. It's been 15 minutes. I'm explaining on these values. Only 2 or 3 students are listening to the class. And what's the use of taking online class? Every day I'm asking you if there are any doubts, you can ask me. No one answered. And how will you calculate this in your end term exam? Lakshmi Narayan, do you know the value assignments?
Yes, ma'am. Yes, ma'am.
Mangala, did you know value assignments? Mangalsana, Mangalsana, did you know the value assignments? So she left the meeting. I asked the question and she left the meeting. So I'm going to mark all these students. This will be your internal marks. One is listening to the class. Every day for 1 hour I'm shouting. If Mangalsana Varepam left the class when I asked the question. So Mangalsana Varepam, where is Mangalsana Varepam? Roll number 54. Tommy Prem, did you know the value assignments? Which is right on your screen right now. Tommy Prem. Prem, did you know the value assignments I have written down here?
Ma'am, I'm not that sure.
Huh? Please repeat. I couldn't hear what you say.
Ma'am, I'm not that sure about that.
This roll number 7 also left the class. And simply they will be telling there is network problem.
Ma'am, hello, ma'am.
Yes.
Ma'am, it's me, Warpa Mangasana, ma'am. My network got cut off.
Hmm. So did you know the value assignments I have just written down in the current slide which you are seeing right now?
Ma'am, for N, R, and that, I know, yes.
What about small r and capital R?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am, I know that.
Okay, what about P? Here, what about porridge? Porridge, what is the small r value? If I want to calculate the final term for porridge instead of coal, if I say porridge here, what will be the small r value?
Ma'am, 1.
You tell me how?
Ma'am, ma'am, because it's in the relevant document.
Okay, porridge is there in the relevant document. So, since we have only one relevant document, the small r value for porridge will be 1. Okay, correct. Hello?
No, ma'am.
Oh, I asked you go in Lora Torag. In Baroda. Hold on. Next one is Saket Kumar. Saket Kumar, roll
Yes,
number
ma'am.
43.
Yes, ma'am.
Okay, so if I want to calculate for uh, 9, NINE 9, what will be the value of r, small r? If I want to calculate for 9,
0.
for 9 it is
0.
0. Why?
And 9 is not in relevant.
9 is not in
Relevant.
11th document. So small r value for 9 will be 0. What is the value for capital R? Saket Kumar, what is the value for
And
capital
1.
R?
And 1.
1. Why?
Because it is in the relevant document.
What? It is in the relevant document.
And it
I'm
is given.
asking
It
why
is given in
capital
the table.
R value is 1.
And it is given in the table.
Huh? It is?
Given in the table. Values.
Value is not I'm just writing for your understanding purpose. It is not given. These two values are not given.
Okay, ma'am.
I'm just writing this for your understanding purpose so that you can understand it. It is not given. The only given thing is this one. Document 2 is relevant. This is the
Yes.
given one. So can you tell me why capital R is 1? Capital R value is 1.
Because the document 2 is only relevant one here.
Yeah, because the only relevant document here in the given example is document 2. So we have only document 2 as relevant document. So our capital R value is 1. Next, Yashwant Kumar, Yashwant, Yashwant, are you there? Yashwant Kumar Reddy, Yashwant, Yashwant is not there. Roll number 10. Yashwant is not. Yeah. Okay, next coming to Siddharth, Siddharth Singh, Siddharth Singh. Okay, so one question for you. In this given example, what is the n value for hot? This small n for hot. H-O-T, hot. Small n for hot. Small n for hot. small n for hot. So that Singh, you don't know, right? Next, Soumya Anand. Soumya Anand, roll number 58. Soumya Anand, roll number 58. Soumya Anand, roll number 58. Okay, so it's not funding. So roll number 58 is absent. Next, Magdalene. Magdalene, roll number 30.
Yes, ma'am.
Okay, can you tell me the small n value for hot?
2.
2. Why?
Because the term hot is mentioned in document 1 and 4.
So term hot is, it is present in document 1 and 4. So the document frequency for n will, for hot will be 2. Correct.
Yes, ma'am.
Next, Harish Kumar, roll number 12.
Yes, ma'am.
Okay, one question for you. What is the n value for P? You can for n value for P. Small n and capital small r. Tell me both the values. Small n and small r for P. Small n and small r. Small n and small r.
I don't know, ma'am.
Akash, number 2.
Yes, ma'am.
You tell both the values for small n and small r for P.
No idea, ma'am.
So easily you are telling me that you don't know, you don't have any idea. So that means you did not listen to the class, right? If you keep on doing this, then how will you calculate all these things in your end term examination? Simply you cannot copy the values from here. In exam, I may ask another document. So if you don't know how to calculate basic term width, final term width, how to assign the values for small r, for small n, then how will you calculate? All of you will get negative marks, no? Aravind,
Yes, ma'am.
you tell me the value for P, for a small value for small r and small n for P.
Well, small n is nothing but number of documents containing their term, so it will be 3. P is there in
Okay.
three documents.
Okay.
And smaller is nothing but number of relevant documents containing term T,
Mm, mm,
small r.
mm.
So it will be 1.
It will be 1. So for P, capital N will be 3, since it is there in 3 documents, document D1, D2, and D5.
Yes, ma'am.
And small r value will be 1 because the
It is a
relevant
relevant document.
document, yeah, it is in relevant document, P in document 2. So
Yes.
small r will be 1 and small n will be 3. So if you
Yes.
know these values, you can directly substitute in the formula given here, final term with formula given here, and you can calculate. And the result you obtain, it will be similar to the this values given WT. You can see down in the here WT. For coal, final term weight is minus 0.33. For day, final term weight is 0. For heat, it is 0. For hot, it is minus 0.33 and so on. So for P porridge spot, the values are 0.262, 0.62 and 0.95. So this is the final term weight for the terms given in the document. So we have calculated for all the terms here, but in the exam, some query may be given and you may be asked to find only for few terms. Instead of finding for all the terms, you may be asked for finding for a few terms. So this is how we calculate the final term weight, which is also known as improved ranking or BN0 model. So in an exam, if I say BN0 model, then you have to remember improved ranking using the formula given here. You have to calculate BN0 model. If I say, you have to calculate using this formula. So once again, let me tell you what is capital R, what is capital N, what is small n, and what is small r. So in normal basic term weight, we need only capital N and small n. As you know, capital N is the number of documents in the collection, is the number of documents that contain the particular term T. So at 0.5 is usually a constant which we assign for finding the basic term weight. So this is about basic term weight. When I say improved ranking, we have different formula because the ranking, we use the ranking method here. How? By putting the relevant document and also by putting the document frequency of the relevant document. So this here, these are here capital N, same with the previous one, small r, it is the number of relevant documents containing the term T. So this we are going to check on in the relevant document. And small n, number of documents containing term T, and small capital R, number of relevant documents. Suppose in this example, as I told you, document 2 and document 4 are relevant, So in this case, our capital R will be 2 because we have two relevant documents, document 2 and document 4. Document 2 and document 4. So now, now you consider document 2 and document 4 are relevant. Okay, consider document 2 and document 4 are relevant. Now I am going to find the final term weight for pot. I am going to find the final term weight for pot. So you tell me the parameter values here. Tell me the parameter values for pot. So what will be the capital R?
2, ma'am.
2, because we have two relevant documents, document 2 and 4. So our capital R value will be 2. And what will be small r for pot? Small r for pot?
Ma'am, 2 pot.
2. 2, because we have two relevant documents, right? 2
Yes,
and
ma'am.
4. And also this particular term port, it is there in document 2, it is there in document 4. So our r small r value for port will be 2. And what about the small n?
2.
It is also 2. It is also 2. This is number of documents in the collection, number of documents that contains the term pot in the collection. So in our collection, we have document 2 and 4, which has pot. So our frequency, document frequency for pot will be 2. Our relevant document frequency also 2, because our relevant documents are what? 2, 4. In 2, 4, we have pot. Pot is there in document 2, pot is there in document 4, like this. Okay, and you can substitute the formulas, substitute the values in the formula given here, then you can get the value here. Okay, so this is improved ranking. And one second. Again, we have Occupy BM25. This is BM0. We have BM1 and BM25. Two more models are there. We will explain this in our next class. But anyway, let me check once again. Okay, you can just see the formulas given here. I think I have already sent this one. If not, I will send today. We'll just check if I send this one. Why? Occupy models. These are all Occupy models. Did you receive this one?
Yes,
Yes.
ma'am.
Okay, fine. So here we have all the Occupy models which we will be learning. And one second, sir. Okay. So basic term width, the formula which we have learned yesterday, and for improved ranking, which is BM0, for BM0 also, which we have learned today, and BM1, that best match 1, here nothing but this WI which we have calculated in BM0, that value is here. That value is here. Okay, that value is this WT. This value is WT. So when we calculate BM1, first we need to calculate this value. BM0's value, we have to calculate this value. So that value multiplied with term frequency in the query, and we are using K3, one parameter here, and term frequency in the query. So we have added a new parameter K3 here. Okay, so this first part is nothing but this result of BM0, this one WI or WT. This part we will be adding here. We will be putting here multiplied by this second part. Multiplied by the second part is nothing but term frequency in the query. Term frequency in the query. K3 is the parameter, scaling parameter. So here. So BM0, BM1, and BM25. These are three Occupy models we will be studying. BM1 and BM25 we will study tomorrow. So here also the same thing. First part is same. W1 is nothing but this BM0 value. So BM0, the whole calculation we represent by W1 or WT or WI. Okay. So in this we have just put W1. So this W1 It is there in BM1. You can see here the first part is W1 multiplied along with term frequency in the query. Term frequency in the query. K3 is the scaling parameter. Okay, we will be assigning some value for K3. And BM25, it is also similar. Here in BM25, the calculation will be a little different because we will be including the document length. Document length also we will be including in the calculation. So the first part W1 is same, and here we have three parameters K1, K2, K3. K1, K2, K3. So that second section calculation is here, and in third section average document length and document length we are going to put in the calculation. And we have another parameter capital K which is calculated using the given formula here. So just calculations, two calculations we will see here. See the parameters WT term width, it is based on your this BM0, okay, that BM0 width here, and term frequency, term in the document, term frequency for the term in the query. So we have two parameters here in document BM25. The numerator part here you can see TFTD. TFTD is nothing but term frequency for the term in the document, and TFTQ. TFTQ, it is nothing but term frequency for the term in the query. So in the query you have to count the term frequency. The other one is in the term frequency. Sorry, in the document you have to find the term frequency. So two different things are here. Then K1, K2, K3B, these are the tuning parameters, or also it is called as scaling parameters. DL and AVG DL, they are document length and average document length. Okay, so these are all the parameters we use for calculation of BM25 and BM1. Yes, BM1 and BM25. So calculation explanation we will do. For that, let me a quick roll call. Roll number 1,
Present, ma'am.
roll number 2,
Present, ma'am.
roll number 3,
Present, ma'am.
roll number 4,
Present, ma'am.
roll number 5,
Present, ma'am.
roll number 6,
Present, ma'am.
7,
Present, ma'am.
roll number 8, Daya Sagar, roll number 9,
Mine present, ma'am.
roll number 10,
Present, ma'am.
roll
10
number
present, ma'am.
11, Chaitanya Agarwal, roll number 12, Harish Kumar,
Present, ma'am.
13,
Present, ma'am.
roll number 14,
Present, ma'am. 14
Harvinda,
present, ma'am. Present, ma'am.
roll
14
number
present.
15, Deepak
Present,
Kumar,
ma'am.
roll
Present,
number
ma'am.
16, Herojit Kharibam, absent. Roll number 17, Janendra,
Present, ma'am.
roll number 18, Abhishek Hudrom,
Present, ma'am.
roll number 19, Jagdev, 19, Jagdev, absent. Roll number 20, Emmanuel,
Present, ma'am.
roll number 21, Keshav Kumar,
Present, ma'am.
roll number 22, Jackson Koizam,
Present, ma'am.
roll number 23, Praveen, just give me one. Okay. Where is his roll number? 22 later. 23. Ravin.
Present, ma'am.
24. Nishita. 24. Nishita. Nishita absent. 25. Ganapati.
Present, ma'am.
26. Lelisha. 26. Absent. 27. Manjeet.
Yes, ma'am.
28. Lunolan.
Present, ma'am.
29. Mayank.
Present, ma'am.
Roll number 30. Magdalene.
Present, ma'am.
Roll 1.
Present,
Thank
ma'am.
you.
Present,
Roll
ma'am.
number 32. Mangalsana.
Present, ma'am.
34. Kartik.
Present, ma'am.
35. Sorry, 34. Suchitra. Suchitra. Okay, 35. Niket Kumar. Niket Kumar absent. 36. Vivan.
Present, ma'am.
37. Vishnu.
Present, ma'am.
38. Hemlet.
Yes, ma'am.
39. Raj Gupta. Roll number 40. Paurai Kasum.
Present, ma'am.
Roll number 41. Riti Agarwal.
Present, ma'am.
Roll number 42. Rengsai.
Yes, ma'am.
43. Saket Kumar.
Yes, ma'am.
44. Robinson.
Present, ma'am.
45. Satyam Sachan. Satyam absent. 46. Siddharth Sinam.
Present, ma'am.
47. Shubham Kumar. Shubham Kumar absent. 48. Somitem.
Present, ma'am.
49. Siddharth Singh.
Yes, ma'am.
50. Naite.
Present, ma'am.
51. Srishti.
Present, ma'am.
52. Rakesh.
Present, ma'am.
53. Sweta.
Yes, ma'am.
54. Mangalsana.
Present, ma'am.
55. Arvind.
Present, ma'am.
56. Abhishek. Absent. 57. Vishal. 58. Soumya Anand. Soumya Anand absent. 59. Krishnanand. Krishnanand absent. Roll number 60. Akhilesh Johan. Akhilesh absent. Roll number 61. Vishnu. 61. Roll number 62. Lakshmi Narayan.
Present, ma'am.
Roll number
Hello, ma'am.
Vinay Kumar.
Ma'am,
Present, ma'am.
hello, ma'am.
Yes.
Ma'am, 58 is present, but she's having network issues. So,
Ma'am,
he has
11 is
messaged
also
you.
present. He has written in the chat box.
No, why didn't she answer when I call her for asking the question? No, she can even leave a message here. When I only call the roll call, she started saying network issue. Why she didn't answer when I was calling her for asking the question? So I'm putting action.
Ma'am, roll number 11 is present. He is written in the chat
Ma'am,
box.
ma'am, at that time, her network issue was so abrupt that she was not able to open the meet.
How did you know she tell her? Did she tell her? Did she tell you?
Ma'am, at the last minute, her network has been. What is it?
Okay, fine. No, network issue, I understand everybody has network issue. Even in my case also, I face lot of network issue. But every time telling network issue is not Like, it's not a good thing, no? Okay, anyway, let's continue in our next class.